Andy? Had enough?
I think so, Blake. Power steering does feel lumpy. I guess the owner was right. You know what threw me at first was his report that the steering wasn't as free and easy as it was before.
That shows how a road test helps. No matter how the owner describes a condition, it takes a test to know what he really had in mind. Let's get back to the shop. We've got a reception committee, Andy. Chris and Tech finished their road test before we finished ours. They've even got their work underway.
Hi, mates. Chris and I have got a carburetor job. How about you?
Power steering here, Tech. It's something all of us should be in on, so why don't you and Chris give us a hand first? Then we'll help you with that carburetor.
I don't know, Blake. I'm not up to date on the latest power steering changes.
Well, that's no excuse, Chris. I'm not sure I know from beans about AFB carburetors.
Now listen, here's a chance for both of you to brush up on something you ought to know. How are we going to manage around here when one of you wants to go on vacation?
Say no more. How can I help on the steering job?
Well, lumpy steering can be caused by low fluid level, a slipping belt, low pump pressure, or some internal condition. Suppose you help Andy check those possibilities in that order.
Okay, I'll check the fluid. Okay, here. Fluid level's right up to the mark.
Fine. Now check the pump belt. It should be free from oil and grease, for one thing, and on this model, the belt should be tightened to 60 foot-pounds torque.
This belt tension's right on the nose, and it's nice and clean.
Good. Now install this pressure gauge. Then we'll start the engine and see if pump maximum pressure is up to specifications for this model.
Okay, Blake, we'll do.
Pump pressure's okay, fellas. So's fluid level and the belt tension. The trouble must be inside the unit.
Right, Tech. Let's remove that unit and get it over to the bench where we can look inside of it. Partially disassemble the unit to remove the piston, worm shaft, and cross shaft, Andy. Then clean the parts carefully so we can check them for wear.
We'll have those parts ready in a little while.
Say, notice that this is one of the earlier units. It has a synthetic rubber D-ring on the power piston. The rounded edge of this D-ring should extend above the piston flange. This one doesn't. It's worn so much, it is letting fluid leak past the piston flange. Whenever you find a synthetic rubber D-ring in one of these units, replace it with the new cast iron ring that's now available.
Well, does that cast iron ring make a better seal?
It sure does, my boy. The metal ring seats in quicker, even if the piston bore is a little rough.
Tech's right. And as you probably know, if the bore were badly scored, you'd have to replace the housing. In our case, here, installing the new ring package will do the trick. There are two packages, by the way. One has the cast iron piston ring and a synthetic rubber seal ring. These same parts, plus a retainer to protect the seal ring, make up the second package. So let's install the new rings on the piston and lubricate them with Type A automatic transmission fluid. Next, install the piston and worm shaft assembly into the housing carefully so the rings won't be damaged.
Okay, Blake, I'll watch it. You know, I wonder why they don't use the cast iron piston ring in production.
Wonder no more, Andy. A new piston, cast iron piston ring, and synthetic rubber seal ring are in current models, along with a new housing. Units with these new parts are identified by the letter H, or letters following alphabetically, stamped between the mounting bolt holes. The new piston and rings are not interchangeable with former parts and can't be used in the early housing. So use the new type housing, along with the new piston and worm shaft assembly, if you replace a damaged housing.
I understand, Blake.
Good. Now, those new parts will correct the condition in this gear, so let's get it back in the car so we can talk about how to correct a case of power steering chuckle.
That chuckle really isn't funny. Some owners don't like the chuckling noise sometimes heard when driving over rough, choppy roads at 5 to 10 miles an hour.
What can cause that?
Well, certain clearances are necessary in a hydraulic gear, so some noise on really rough roads is normal. But if noise seems more than standard, backlash between the cross shaft and piston teeth might be excessive. The cross shaft adjustment should always be checked at the 1,000 or 2,000 mile inspection to take care of the slight wearing in of new parts. We'll have to check it on this car. Loose lower control arm struts can also cause chuckle. Rear mounting bolt nuts should have 65 foot-pounds torque. 30 to 35 foot-pounds is specified for the forward nut. Sometimes front shock absorbers make a sort of chuckling noise when cold, which is only normal. This noise disappears as soon as the shocks warm up.
I see, Blake. And I guess I'd better know how to adjust the cross shaft.
Right. You first center the steering wheel with the front wheels straight ahead. Disconnect the center link. Then with the engine running, so you get the right feel of the mesh, loosen the adjusting screw lock nut and turn the screw out until you can feel a little backlash. Then turn the screw in until backlash disappears. Finally, turn the adjusting screw in 3/8 to 1/2 turn. Torque the lock nut to 50 foot-pounds.
Okay, Blake, that's plain enough.
Good. Now, would you like to hear about another power steering condition?
I would, Blake. What did you have in mind?
Poor returnability on a left turn, Chris. In this case, you'd want to be sure that front-end alignment was up to specifications. And if alignment is okay, check position of the control valve to be sure it's right. If it's okay, then you'd suspect some internal restriction was keeping the gear from returning to normal straight-ahead position following a left turn.
Well, what could that restriction be?
Well, the column jacket might be assembled too high on the jacket support of the power unit. If that has happened, the slot in the lower end of the steering tube will bottom on the tube connector pin. This pin must be so located in the slot to allow a slight up and down movement of the worm shaft. This movement controls valve operation.
Oh, I get it.
Good. So let's loosen the jacket clamps. Push the jacket down against the shoulder on the jacket support. If there's a rubber insulation boot used, the jacket end should rest on the flange of the boot. If returnability is still poor, after relocating the jacket, remove the steering wheel and jacket. See if the spacer washer is assembled under the jacket bearing, or if the washer is missing. That washer, assembled between the snap ring and lower end of the jacket bearing, controls upward movement of the tube. It also maintains proper clearance between the steering wheel hub and top of the column.
I see.
Now, there's supposed to be only one washer below the bearing. Don't you dare install any others.
Attaboy, Tech. Good point. Extra washers at that point will not only affect steering on a left turn, they can completely hamper returnability from a right turn.
Okay, Blake, clear enough. Anything else?
Right now, somebody better turn this record over. We'll cover more steering conditions on the other side.
Whenever you service a power steering unit, be sure to notice the letter on the housing, so you keep in mind some of the changes made during production. For example, in a unit stamped with the letter J, you'll find a new spring-loaded pivot valve lever, along with a new valve housing. This does a lot to improve returnability from turns. Here's what the parts in this change look like. The shank of the valve lever has a smaller diameter. This permits installation of a coil spring, which sits on a shoulder right above the lever's spherical section. The spacer and race are also new to go with the new lever. Pressure of the spring holds the lever more firmly seated in the spacer. As a result, friction in the valve centering system is reduced and returnability is improved.
Sounds pretty neat. Anything else on power steering?
There are a few minor items on correcting occasional rattles and a lack of feel of the road, Chris. But you'll find them all spelled out in this reference book.
Swell, Tech. I'll be sure to look those up.
Do that, Chris. Now, I suggest we leave power steering and take a look at that car you think has a carburetor condition. Are you really sure it is the carburetor that's at fault?
Well, I don't know what else, Blake. We checked ignition, the distributor, spark plugs, timing, the works. Everything was okay. And yet, the engine would stall in neutral or in gear after a cold start.
Did you happen to check the manifold heat control valve?
No, I mean, not yet. Just how important is that?
It's vital. And a good thing to get out of the way first.
Tech's right. If the heat control valve sticks open, hot exhaust gases won't warm up the intake manifold, so it can vaporize fuel properly. Engine warm-up will be poor, and it'll stall. It can even cause a stumble on acceleration and poor fuel economy to boot. Just move that counterweight back and forth against the tension of the thermostatic coil. It should turn freely and return to closed position. You can free up a sticking shaft with this heat control valve solvent. Be sure the valve is cool and let the solvent soak in several minutes. Turn the shaft back and forth to loosen it up. With the engine idling, you can test the valve by accelerating to wide open throttle momentarily and then releasing the accelerator quickly. The counterweight should rotate about 1/2 inch clockwise and return to closed position. Sluggish action or no movement means the shaft is binding. No return to closed position means the thermostatic coil is weak or broken.
Well, our valve's working okay. What next?
Well, when you checked timing, did you make sure you didn't get a slight automatic advance? In other words, did you disconnect the vacuum line between the distributor and carburetor?
Yep. We checked timing with the line disconnected and with it connected. Tech told me that if the throttle valves didn't return to idle, the vacuum advance port would be exposed. When setting timing at idle, he said we don't want any advance, vacuum or mechanical. So we disconnected the vacuum line and taped the connector closed to keep engine speed the same. Then we used a timing light to set timing at the recommended idle speed. We then connected the line and checked timing again. Both readings were the same and up to specifications. So we knew vacuum wasn't affecting timing.
Nice going. If you had found a difference in your readings, you'd have to remove the carburetor and reposition those throttle valves, or free up the throttle shaft. Okay, suppose we check fast idle adjustment now. It's got to be high enough to keep the engine from stalling during warm-up. So, remove the air cleaner. Partially open the throttle valves to release the fast idle cam. Close the choke by hand. Hold it closed and release the throttle valves. This should move the fast idle cam to the position giving the correct fast idle speed, according to the specifications of the car you're working on. On this AFB carburetor, the index mark on the cam should line up with the center of the screw. If it doesn't, or if the idle speed is not right, an adjustment is needed. Get the fast idle cam in the right position first. You may have to bend the connector rod at the angle until the index mark does line up with the screw. Then adjust the screw to get the correct fast idle speed.
Well, fast idle on this carburetor's okay. What's next?
Well, we checked ignition, timing, the heat control valve, and fast idle. All were okay, but the engine still stalls. It's a safe bet that the choke opens too much during engine warm-up. So let's change the length of the vacuum piston link.
Well, how do you do that, Blake?
There are two methods. On this carburetor, remove the cotter pin from the choke lever. Then take a 1/16 diameter wire, about 1 3/4 inches long. Put one end through the two holes in the choke lever so it sticks out about 1/8 of an inch on the short end. Bend the long end around the bottom of the lever to form a U with uneven sides. Remove the wire from the lever. Pass the long end through the hole in the link and the short end through the holes in the lever. Hold the wire tightly against the lever and bend the long end behind the short end extension and over the top of the lever. That'll cut down the choke opening at idle and light load running during warm-up.
Now, occasionally, that might cause loading or too rich a mixture. If so, use the alternate correction Blake can tell you about.
Well, how does that other correction go?
Well, you remove the cotter pin and the Welsh plug. Pull out the piston and link. Drill the link holes oversize to 9/64 inch. Reassemble the piston and link and install a new Welsh plug.
Incidentally, the wire fix applies only to crossover type chokes with AX identification on the cover. Enlarging the holes can be done on either AX or AU mark chokes.
Good point, Tech. On the integral type choke, you'd remove the retainer ring, cap, and thermostatic coil. Remove the throttle return spring to set throttle 1/4 open. Let the choke valve go wide open. Insert a 26 thousandths gauge into the choke piston slot so the end hook enters the slot in the cylinder. Push on the choke lever clockwise to trap the gauge between the piston and cylinder slots, leaving the choke linkage free. Bend the choke connector rod at the upper angle to provide an 11/64 inch opening between the choke valve and wall of the air horn. Remove the gauges, reassemble the choke, set the thermostatic coil cap 1 notch rich, and install the throttle return spring.
Pretty neat. Any other carburetor corrections?
Well, occasionally there's a report of a hesitation or flat spot on acceleration after warm-up. This shows up at speeds just above 20 miles an hour. If compression, ignition, and timing are okay, chances are the mixture's too lean. On Plymouth, with the BBD carburetor, install a stronger pink-colored step-up piston spring. Also, on cars with manual and overdrive transmissions, install richer step-up wires, 20 thousandths diameter, in place of the standard 22 thousandths wire.
Hey, how about the other models like DeSoto or Chrysler?
On the DeSoto BBD carburetor, install richer step-up wires, 27 thousandths, to replace the standard 29 thousandth size. Also, set the accelerator pump for the long stroke in cold weather.
On DeSoto AFB carburetors, install the new, richer step-up rods with the standard 89 thousandths jets. Don't use richer step-up rods with the 91 thousandths jets.
How about the pump stroke?
You might have to set it for the long stroke in cold weather, but only if a road test indicates it's necessary.
How about the Chrysler models?
Well, on Windsors using BBD carburetors, richer step-up wires in place of standard wires will improve performance. And on Chrysler cars with AFB carburetors, replacing the standard step-up rods with slightly richer step-up rods will help. More information on this, along with other corrections, is in the reference book.
There are extra up-to-date tips on other parts of our cars in that book, fellas. Be sure to look them over.
Okay, Tech. We'll really study the book.
Attaboy. The more you know about these current service conditions, the better you'll meet the needs of our owners. That, of course, keeps us high on the customer hit parade.